welcome to Ethical Hacking and Penetration Testing, brought to you by Eduonix. This is Chapter 6, Web Exploitation Techniques. So the topics that we're going to be covering are web testing tools, exploiting SQL injection to full system access, exploiting blind SQL, RFI, local file includes, file uploads, RC and XSS, DOS attacks, and attack countermeasures. So as far as web testing tools go, we need to look at what OWASP is. What is the OWASP Top 10? The OWASP Top 10 provides a list of the 10 most critical web application security risks at the minute. It changes all the time. The OWASP Top 10 is a powerful awareness document for application security. It represents a broad consensus about what the most critical web application security flaws are at any one time. Project members include a variety of security experts from around the world who share their expertise to produce this valuable list. I would definitely urge all companies to adopt awareness of it within their own organization and start the process of ensuring that their web applications do not contain these flaws. Adopting the OWASP Top 10 is probably the most effective first step towards changing software development culture within your organization into one that produces secure code. So for each risk, it will provide a description, an example of a vulnerability, an example of an attack, guidance on how to avoid it, and references to OWASP and other related sources. So let's have a look here. So here we have the OWASP Top 10 mobile risks. I only say mobile because a lot of the things on here are mobile related. Some of the other ones to do with servers and things are less interesting. There isn't a list for 2015 yet, but we can look at the top 10 mobile risks for 2014. So M1 is weak server-side controls. If you click on it, it will give you application spec, the exploitability factor, security weaknesses, technical impacts, and business impacts. And it gives you a lot of information on exactly what they are as well. So next one, we have insecure data storage, then we have insufficient transport layer protection, unintended data leakage, poor authorization authentication. So look at that. So the application specific here is threat agents that exploit authentication vulnerabilities typically do so through automated attacks that use available or custom-built tools. A threat against that exploit authorization vulnerabilities typically do so through automated attacks that use available or custom-built tools. I won't read all this, there's quite a lot, but you should have a look at owasp.org. So let's have a look at exploiting SQL injection to full system access. SQL is used in everything these days, it really is. It's probably Microsoft SQL and Linux, MySQL, probably the top two database tools that you can use out there at the minute. So SQL injection is a code injection technique that exploits a security vulnerability occurring in the database layer of an application. In other words, a SQL code injected in as a user input inside a query. SQL injections can manipulate data, i.e. they can delete, add, update, etc. And corrupt or delete tables of the database as well. There isn't any SQL injections that manipulate scripts though, that we know of. So let's say your PHP script that you're expecting as user input, a username and a password from the login form that are later used inside a query such as select ID from users where name equals $name and password equals $password. So this particular user input, $name and $password, or whatever he likes, for example, through input. Let's imagine you add something like this here, which is quote 101 equals 1 semicolon dash dash, and then close the speech marks. The query would then look like this. Select ID from users where name equals 1 or 1 equals 1, colon, dash, dash, and password equals password. And then, after the colon, you could add another query to make the script think that username or password actually exists. So notice that dash, dash, and password equals $password is a SQL comment and will then probably be ignored. Well, not probably, it will be ignored. So exploiting blind SQL injection to full system access. So what exactly is the difference between blind SQL injection and normal SQL injection? Well, in normal SQL injection, hackers rely on error messages returned from the database in order to give them some clue on how to proceed with their SQL injection attack. But with blind SQL injection, the hacker does not need to see any error message in order to run their attack on the database. And that is exactly why it's called blind SQL injection. So, even if the database error messages are turned off, a hacker can still run a blind SQL injection attack quite easily. So as an example here, let's suppose that we've got a fake example of a social media network here called mybigspace.com, and let's call it ID 1008. It's got different profiles for people just like Facebook, and each user on the site mybigspace.com has a unique ID number assigned to them that identifies their profile. And a query string is used to retrieve each individual profile. So in the URL below, the user with the ID of 1008 will be pulled up and displayed on the page. So let's say that the user ID of 1008 belongs to a user named John Doe. Here's what the URL that you used to load John Doe's profile would look like. http mybigspace.com !ID 1008. So let's assume that the user ID would be used to retrieve the user's profile details, like links to pictures, birthdays, etc. from a database. So if a user requests that the URL is here, then that query string would be used to return some SQL on the servers of mybigspace.com. That SQL could just as easily look like this. Select star from profiles where ID equals 1008. We're assuming that there's a master table called profiles, which stores all different profiles of people who are on the social networking site. So the theory is you could change 1008 to 1007, you would get somebody else. That is how things like MySpace used to be set up as well, by the way. So let's have a play around. So let's say the hacker tries to inject some SQL into the URL query string. So the hacker tries to load this URL into their browser. mybigspace.com !ID 1008 and 1 equals 1. So blind SQL injection uses simple Boolean expressions. So yes, if you load the above URL in the server of mybigspace.com running SQL, note that the SQL contains a simple Boolean expression, which of course will always return true because 1 is always equal to 1. That expression is appended to the query string in the URL. So as we say, we discussed select star from profiles where ID equals 1008 and 1 equals 1. And we said that loading the URL might result in myBigspace running the SQL above. The reason we say might is because of the fact that it depends on whether the server would allow the extra characters after the 1008 to be injected into the SQL. If the server does accept that SQL is allowed to be run, then the page that belongs to John Doe will be loaded just fine. And the hacker will know that SQL injection attack worked, which means that the site mybigspace.com is vulnerable. So blind SQL injection can be used for testing it, and then the results of the blind SQL injection can be used for an actual proper exploit, like a good hard SQL injection attack. Of course, if the server doesn't respond with John Doe's page when you load that particular bit of script, and it just returns something like page not found, then the hacker knows that the blind SQL injection is probably not possible. So let's continue with the assumption that the website is vulnerable to blind SQL injection. Now the hacker can use a more sophisticated query to gather information about the server environment. He can work his way into getting some potentially sensitive data. For instance, if the hacker wants to find out which version of MySQL the server is running, assuming that there is a running MySQL database there anyway, the hacker could try and load this URL, which has some extra SQL appended to it to check, see if the server is running MySQL version 5. So chances are, if mybigspace.com isn't running MySQL Server 5, then SQL string add version 1,1 equals 5 will return false because the check for equality is false. This means that the page will probably not load because the profile will not be retrieved, so the hacker knows that the version of MySQL running isn't version 5.